Okay. Good afternoon. We are using more learning more log things today. So we have properties of logs today, and our goal is to be able to expand, but really we're going to use them to condense logarithms using properties of logs, which actually come from properties of exponents. So remember, a logarithm is just the inverse of an exponent. So everything is really closely related to our exponent rules. So for instance, just to recall, what is something like, if I have x to the 5th times x to the 7th, x to the 5th times x to the 7th is x to the 12th. What did we have to do? Add the exponents. Yeah, if they have the same base, all we have to do is add the exponents. So in logarithms, and this is a product, we're multiplying them together. So in a logarithm, if I have a single logarithm, and inside the logarithm is a product, so this is the product property, I can expand it. Now that expand means we're making it bigger, so we're going to have to end up writing log over and over and over, okay? What we're doing here, the product says we're allowed to add the logs, much like we were allowed to add the exponents. So the log of the quantity m times n becomes the log base b of m plus the log base b of n. So we're allowed to add the logs. And so that's making it a much longer statement, okay? So the reverse is also true. If I'm starting here, I can condense things to a single logarithm. So if I see a log plus a log, I can condense it using the product rule, okay? And so here I have my log, and you'll notice the bases match. Can I do this if the bases don't match? No, the bases have to be the same. All right, so I want to condense to a single logarithm. I love this instruction because I've had, many years ago, the instruction was just condense. And as many times as I'd say to a single logarithm, and then you'd have students, I'd have students who would write many logs. But how many logs are we supposed to have? Just one, because it says single. All right, so I know I had a single log base 3, and what do we get to do with our, so the thing that allowed me to add the logs was the product property. It turns into multiply, 9 times 5. So we're sort of doing the reverse of this. We have the sum of the logs, we get to reverse and have the product of the two things, which is log base 3 of 45. Again, what's the base on these logs, on number 2? 10, very good, log base 10. So we're going to condense it to a single log base 10 of, what do we get to do when we have the sum of logs? Good. We get to multiply those arguments together. So we're multiplying 6 times the x minus 3 argument, which we could distribute if we wanted to. Log base 10 of 6x minus 18. Here, is this a log? Yeah, what is it? Log base e, remember. So those natural logs really just mean log base e. So again, I can keep it just using natural log. If we wanted to make it log base e, we could. But the sum of the logs, I can rewrite as a product. So we have 4x squared times 3x cubed. Can I clean that up inside? Yeah, so we have 4 times 3, which is 12, and what's x squared times x cubed? X to the 5th, good. This is really quite weird here. This is so weird how she has this here. I don't want to do that. We're going to skip that and come to some other things later. The next property we have is the quotient property. And again, going back to exponents, quotient is division. So if I had x to the 8th over x to the 2nd, so I had a quotient, I had a division problem. What is x to the 8th over x squared? No. X to the 6th, yes. What did we have to do to the exponents? Subtract. It was 8, subtract 2. So instead of up above we were adding the exponents, we're subtracting the exponents, okay? And so related here to logarithms, if I have a quotient trapped inside of a log, I can expand it using, what operation do you think? Subtraction. Yeah, we added the logs here. What are we going to do in a quotient? Subtract the logs. So log base b of the top minus log base b of the bottom argument n. So I'm just going to do just like a couple here. We want to condense this to a single logarithm. So again, I have a natural log. What allowed us to subtract the logs? What property allowed us to subtract logs? The quotient property. So we're going to take the quotient, and it's going to be top 96 over the second thing, 96 over 6. So natural log of 16, it turns out. 96 divided by 6 is 16. Number 8, what property allows us to subtract the logs? Quotient property. So log of what's on top? 8x to the 10th over 4x to the 2nd. Yep. Can we clean that up? And so that inside cleans up to 2. 8 divided by 4. We're not subtracting. These are just numbers. 8 divided by 4 is 2. What's x to the 10th divided by x squared? X to the 8th. Okay. Let's look down here at, number 11. Expand using the quotient property. So if it says expand, that means we're going to have lots of logs in our answer. So let's look at number 11. Using the quotient property, what operation should I do if I have the quotient inside a log? Should I add, subtract, multiply, divide? Subtract, yes. This is going to be the natural log of 3 minus natural log of 4. Yep. What about number 12? How would that one expand? Log of x minus 7 minus log of x plus 1. That's it. All right. The last property that we have is the power property. The power property says if you have a log and the argument has a power on it, that power is going to drop down in front and multiply. So it becomes n times log base b of m. So your powers get to drop down in front. All right? Now the reverse is also true. If you have a number in front of a log, I can go backwards and condense it by moving that number in front right back up to its power position. Let's look down here at number 16 first. Let's expand number 16 using the power property. What happens to my power? It moves, drop your power is what I'll usually say. My power drops down in front, so we get x times log base 2 of 5. Number 17 is interesting because we want to use exponents here. If I have a nice little exponent, my life is easy. What I don't want to see is radicals. So I want to rewrite this natural log of 2x plus 1, and I want to use an exponent instead. 1 over 3. gives me the root. So I'm going to use that exponent of 1/3 instead of my radical. And now what do I do with my power? Move it down in front. Drop your powers. Drop that power down in front. It becomes 1/3 times the natural log of 2x plus 1. All right, so we can condense as well. So if you see a number in front, where did it come from? It's exponent. So we're going to push it back up to its power position. So on number 13, we have log of 6 to the 3rd power. And I could rewrite that if I wanted to. 6 cubed is 216. But you're not going to do these today here. What does this 1/2 want to do? Go up above that 81 in the power position. So I get log base 4 of 81 to the 1/2 power. What is 81 to the 1/2 power? 9. The square root of 81 is 9. So log base 4 of 9. Cool. So those are our 3 powers. Now we're really going to use them on the next page. So this is more of what we're doing today. I like that she starts with condensing, sort of, except that I really feel like expanding. Like this is so reversed for me. So we're going to start down at the bottom here. So starting with 27, we want to expand each logarithm completely. So this is going to have lots and lots of logs. We're going to have to write it over and over again. You can see here we have inside this argument, this says x times y cubed. So first we have a product. What does the product rule allow me to do? Add the logs. So our product rule allows us to add the logs. So I'm going to rewrite log base 7 of x plus, what should my second thing be? Log base 7. Again, lots of logs. We're going to have log 7 written out a lot. Log base 7 of y to the 3rd power. And then what can we do with the last thing? Yeah, we got a power play here. I call that a power play, but it's really the power rule. We have a power. It gets to drop in front of its own little log. So it drops right down in front of its own little log there. So I have log base 7 of x plus 3 times log base 7 of y. On number 28, what operation do we have? Quotient. So this is a quotient rule. All right, what does the quotient rule tell me to do? Subtract the logs. So we have the natural log of m cubed minus the natural log of n to the 7th. So we're subtracting our logs now. And then what should we do? Drop your powers. Yeah, power play here. Drop those powers right down in front. And what would you get then?
3 times ln minus 7 times ln.
Good. All right. So 3 times the natural log m minus 7 times the natural log n. What do we want to do on number 29? Yeah, I don't want to see any radicals. And we want to rewrite those using exponents. And our life will be a lot better. So this is I'm going to rewrite it as a to the 3rd times b to all of that to what power? 1/2. All right. So, gosh, what are we going to do first here? We got to move the 1/2 first. Because it's on the outside, the outermost thing there. So I'm going to move that 1/2. That's a power play. Going to drop that in front. And what do we get? Good. 1/2 log of a cubed b. Now what are we going to do? Add the logs. Yeah, we have a product here. So we're going to use our product rule. And what's tricky is I'm going to expand this part. What do I have to do with the 1/2? Yeah, that 1/2 is going to affect that whole addition thing going on. So I'm going to write it as 1/2 because we have to expand this log, and it's going to have 2 now. So it's going to become log of a cubed plus log base 10 of b. And then we got to move the 3. Can I just do this? Can I cross out the 3 and pop it down in front of its own little log there? I ran out of space. Is that okay? Yeah? All right. Okay, I would like to look at 31 and 32. These are Delta Math ones. Can you take a moment and rewrite these? I meant to do this when I was prepping the notes to clear out the box for you, but I think I got too busy. All right, so number 31, cross out what's there. We have log base 10 of the square root of x to the 5th over z to the 5th y squared. And then number 2 is log base 10 of the cubed root of x to the 4th over y z to the 4th. All right, what should we do first here? Radical, yeah. So I'm going to rewrite that as log of, let's see, x to the 5th to the 1/2 power? That radical is just affecting that x to the 5th. And then on the bottom I still have z to the 5th times y squared. Can I clean that up? X to the 5th to the 1/2? This is a power raised to a power. You do multiply those exponents. Very good. Clean that up just a little bit more. So I'm going to multiply 5 times 1/2 is really just 5/2 over z to the 5th y squared. Okay, wow, finally, I've got that simplified enough for myself. What operation can we deal with first here? Quotient, yeah. So I have the quotient rule here, which allows me to do what to the logs? Subtract the logs, all right? So I'm going to have log of x to the 5/2 minus log of z to the 5th y squared. So top minus bottom with logs, lots and lots of logs. All right. What can I do here with this first thing? Power play, yeah, got power play here. So that power is going to drop down in front. And what's going to happen with our second term here? Yeah, good. So we have a product rule, so we're going to expand the logs. And then they each have a power play. Now this is, we're subtracting. This is really, really tricky. We're subtracting this whole thing. And I don't know what y'all are looking at, but you are going to miss this on Delta Math, and it's just going to chap your hide. We are subtracting this whole thing, and it's going to turn into 2 things added together. So this negative has to affect both of those. So I'm going to go ahead and just put beyond some parentheses there, because we have to subtract that whole expansion, okay? So I'm dropping my power here. We get 5 over 2 log of x minus the entire, what's going to happen with my log of z to the 5th y squared? 5 log of z, plus 2 log of y. Very good. Now, I am not sure what the directions say in Delta Math. I think this is pretty good, but if they want it fully expanded, they might want you to distribute your negative, in which case I'd have 5 over 2 log of x, and I'm going to distribute my negative, so it become minus 5 log z minus 2 log y. Okay, so my powers dropped as well on those powers of 5 and 2. What I would like to point out here is you'll notice the z to the 5th Was it in the top or the bottom of the fraction? Bottom. And it's got a negative in front. Okay. Where was the y squared? Bottom, and there's a negative in front. X to the 5 halves was in the top. What's the sign in front of that? Positive. Can you kind of imagine how you would go from this fully expanded form and condense it right back to here? Can you envision that? Okay. So I'd be like, I'd pop my 5 up to the power, return my 2 to its power, and then be like, it's negative, it was on the bottom. Negative on the bottom, positive on top. And if you can think like that, then this becomes really, really easy. I don't think I want to do another one of those. Let's go up here. So here we are condensing to a single logarithm. Number 19, what do you notice first? They both have the same base. That's key. That's good. So we can write a single log with a base of 4. Very good. What is this 2? Where did it come from? The 9? Scott, you're not on your phone. Of course not. I have x-ray vision. I can see right through. Yeah, you guys think you're so sneaky, but like... I thought you just didn't care. Oh, no, I totally care, man. Because you know what he's going to do? He's going to be like, I don't know what to do.
Yeah, I'm going to do that anyway.
I'm going to be like, dude, I worked really hard to think about how I'm going to explain this to you, and you weren't even paying attention. All right. So that 2 came from?
The 9.
Above the 9. It's the power. So we're moving it back to its power. What about the 3? Exponent. Move it back up above the 2. And then, so I could say, hey, this was 9 to the 2nd power. Okay. Plus, if I'm doing this in this many steps. I don't normally do this many steps. All right. Now they both have a log base 4. And we want to condense it to a single log. What allows us to add the logs? The multiplication, the product rule. So I can write a single log, and we're just going to multiply those together. Yeah, so that becomes 81 times 2 cubed, which is 8. Log base 4 of a big number, 648, which is kind of weird. All right, let's go over here to 22. Again, this is more like what you're going to see in Delta Math. So number 22, I have rewrite number 22 there. 6 log x minus z log a. Where did the 6 come from? Power. Yep, it was a power play. And what about the z? Again, that's a power, so we're going to return it to its little power position there. And so what allows us to subtract the logs? Yeah, the quotient rule. So what I'm going to do to make my life a little easier is to say, hey, here's my single log base 10, and I know it's going to have a quotient. What goes on top? What goes on bottom? Yeah, here it's positive. It's a positive 6 log x. So where did the 6 go? To the x. So we have x to the 6th on top. And what's going to go on the bottom? A to the z. Yes, a to the z. And so if you pay close attention, you can actually clean things up pretty good, pretty quickly. Let's... I don't know why you would do all of these this way. All right. I want to stop there. Are you good with that? Yeah? All right. Yeah. Let's stop there. You've had a Delta Math today.